Hello again, friends. This time we will continue our discussion about Cramer's rule, but for this video we will focus on solving linear equation with three variables. So once again, Cramer's rule, and here we will be talking about system of linear equation with three variables. So let's start. So I will do this video. I will start this video and explain everything with an example. In order to learn the basic about the Cramer rule, you can refer to my previous video on systems of linear equations with two variables. So here, the first equation would be 3x minus 2y plus z is equal to 2. The second equation would be 4x plus 3y minus 2z equals 4. And the third one would be 5x minus 3y plus 3z, it's equal to 8. So here I have three equations and three unknown variables. My unknown variables, which I have to solve for them, are x, y, and z. Okay, so let's start step by step. The first thing we have to make sure our equations are nicely aligned and the order of the variables are exactly the same in each of the three equations. So here we have x, y, z, the same order here, and then the constant is on the other side of the equal sign. So let's start by forming the D or coefficient matrix. The coefficient matrix here would be a 3 by 3 matrix because here we have three variables and three equations. So the first column would be x, the second column would be y, the third column would be z, and let's start putting the numbers. So 3, 4, 5, negative 2, 3, negative 2, 3, and negative 3. Okay, and the third one would be 1, negative 2, and 3. So before I proceed, I have to give you a few reminders. So if any coefficient is missing, you just put 0. Okay, and then second thing, they have to be like in order. So if they are not in the same order, you have to rearrange it and make it in the same order. Okay, so here I form the matrix. This is the symbol, and the size of the matrix, it's the number of rows times the number of columns. Okay, and let me make it clear that x, y, z are not part of the matrix. I just put it to remind myself what each column is for. So this is the matrix, so the corresponding, then I form the determinant, which is D, and this is the symbol, would be 3, negative 2, and then 1, 4, 3, negative 2, 5, negative 3, and 3. Okay, and this determinant is 3 by 3. Remember, so far, we only had a 2 by 2 determinant. In order to find the answer to a 3 by 3 determinant, you have to break it into 3 2 by 2 determinants. Okay, there is quite a lot of calculation you have to do, so let's do it together. In order to find this one, okay, the answer to this determinant, so this is, we only deal with the first row. These are my main numbers. Okay, and here, let's say if you take the first number, which is 3, the corresponding column, okay, the corresponding column and the corresponding row would be eliminated, and what is left, it would be a 2 by 2 determinant. Okay, So the answer would be 3 times 3, -2, -3, and 3. Okay? So the second main number would be -2. But remember, your formula has got a negative sign here. So this is from the formula, and your number is -2. Okay? And here, if I want to eliminate this column and this row, then I would be left with 4, -2, 5, and 3. Okay? So that would be 4, -2, 5, and 3. Okay, now let's talk about the third main number, which is 1. Okay, plus 1. And then, again, if you want to eliminate this column and this column, what are we left with? It would be 4, 3, 5, -3. So here, as you can see, my original 3 by 3 determinant, it's broken down into 3 2 by 2 determinant. In order to find the final answer for this 3 by 3 determinant, I have to find the answer to each of these 2 by 2. So here I have to go and calculate the answer. So 3 times 3, it's 9. Negative, this would be a plus, okay? And here that would be turned into a positive. So that would be 4 times 3, it's 12, minus, it would be -10 plus this one. I change it into positive. Then the third one would be 4 times -3, which is -12, minus 5 times this, -15. So if I add all these together, the final answer would be 26. So D, which is the determinant of the coefficient, it's 26. Okay. So from here, we have to calculate the dx, dy, and dz. Remember, in the previous video, we only had 2 equations and 2 unknown variables. So we only had to calculate dx and dy. But here we have 3 different variables. So we have to calculate dx, dy, and dz. So the thing is, here, each of these determinants would be a 3 by 3 determinant. So that's why, solving a 3 by 3 linear equation by Cramer rule would require lots of patience and making sure you double check your answer every step of the way and make sure you don't make any mistake. Okay, so now let's form the dx. Dx would be, okay, so as you can remember from my previous video, the dx, when we want to form the dx, the x column, which is the first column, should be replaced by the constants. The constants are 2, 4, and 8, and then the rest wouldn't change. So that would be -2, 3, -3, and then the third one would be 1, -2, and 3, which again is a 3 by 3 determinant. Okay, so once more, if we want to calculate it, the main number is 2. 2 times, okay, so let's see here, this one would be eliminated, this one would be eliminated, then I will be left with 3, -2, -3, and 3. The second main number is -2, okay, so that would be -2. This time let's say if I want to eliminate these two, so this one is eliminated, this one is also eliminated. What I left with, it's 4, -2, 8, and 3. Okay, so that would be 4, -2, 8, and 3. The third main number, it's 1. Okay, and then if I eliminate these two, I would be left with 4, 3, 8, -3. Okay, if you calculate any of these, okay, your final answer would be 26. And I leave this one to you. For you guys, it would be a really nice practice. Now let's calculate the dy. First we have to form the dy. The y is the second variable, so the second column would be replaced by the constant, which is 2, 4, 8, but the first column and the third column wouldn't change. So that would be 3, 4, 5, and then 1, -2, and 3. Okay, and the size is 3 rows and times by 3 columns, 3 by 3. Okay, so now let's calculate our 3 by 3 determinant. So the first number is 3 times, this is my main number, so this column and this row would be eliminated, so I'm left with 4, -2, 8, and 3. Then the second main number, okay, the second main number would be 2, and then this will be eliminated, this will be eliminated. I'm left with 4, -2, 5, 3. Perfect. And then the third main number would be 1. So this and this would be eliminated, and I'm left with 4, 4, 5, 8. Okay, so now let's calculate the value of each of these 3 determinants. So 3 times 4 times 3 is 12, minus 8, -16, and then I have 1 negative, so it turns into positive. The second one, it's -2. 4 times 3 is 12, minus 5 times -2, it's -10, times by -1, +10. So here the third one would be 4 times 8, which is 32 minus 20. Okay, if I do this calculation and simplify, the final answer would be 52. Okay, we are not done yet. So far, we only calculated dx and dy. But remember, for this specific example, we have 3 equation and 3 variable. So now I still have to proceed. I have to continue with defining the dz, which is the determinant of z. Okay, dz, it's equal to, the third column would be replaced by the constant, which is 2, 4, 8. The first and second would be 3, 4, 5, and then the second would be -2, 3, -3. Okay, so now let's do this 3 by 3 determinant. Okay, so the first main number is 3 times 3, 4, -3, and 8. Okay, the second main number, it's -2. So this column and this row would be eliminated. -2, and then what's the determinant? So the determinant would be 4, 4, 5, 8. And let's do the third main number, which is 2. Okay, and the determinant, so this column and this row would be eliminated. So what I'm left with is 4, 3, 5, -3. Perfect. Now I have to calculate the value of each of these determinants. Okay, so 3 times 24 minus, this is -12, turns into +12. Here, these two, it turns into +12. 4 times 8 is 32 minus 20. The second one, the third one actually, would turn into -12. Okay, 15 minus 15. Okay, now if you do the calculation and try to simplify everything, the final answer would be 78. Okay, so far we calculated the D matrix, the D determinant, dx, dy, and dz determinant. Now it's time to calculate the x, which is determinant of x over determinant d, which is the value of dx was 26, and the value of determinant d was also 26. So the x value would be 1. Okay, so now let's calculate the y, which is dy, determinant of y over determinant of d. The y, dy was 52 over 26, which is 2. Perfect. And then the third one, the z, would be dz over d, which is 78 over 26, which is 3. Perfect. So far, I calculated my 3 variables, x, y, z, using Cramer rule. But as I mentioned, I'm not done yet. I have to go back to my original equation and substitute the value and make sure, I didn't make any mistake. So going back to my original equation, let's substitute the value in the second equation and see if I substitute for x, y, and z, does it equal to 4 or not? So 4 times the x1 plus 3 times the value of y was actually, I think it was 2. Okay, yes, the value was 2, and then the z was 3. Okay, so it's 4 plus 6 minus 6, so the answer would be 4. 4 is perfect, equal to 4. So that means my answers are correct. I hope you enjoyed this video. Please don't forget to subscribe and share and like my videos. Thank you.